Hello, friends. Welcome back. So now we're on topic 3.9. Feeling kind of sleepy because I had this dream about wheels. And I woke up and I was so tired. And the night before, I had this dream about mufflers, and when I woke up, I was exhausted. So, so what we're going to talk about now is inverses of trigonometric functions. Inverse, right? Super, super simple way of thinking about it is simply that we switch the input and the output. Okay, and so for example, if we have the function, right, so sine of pi over 6 equals 1/2. So we have here. So how do we write inverse, right? If I want to write the inverse of a function, I use the negative 1 notation. So when I see sine to the negative 1, this does not mean 1 over sine. It's not what that means. It's not an exponent. Okay. We're using it the same way we would use f to the negative 1 of x, right? That's the inverse of x. So, to help you with that kind of language, I would recommend not saying sine to the negative 1. Don't say that. When you see it, the words that you use to describe it are inverse sine, okay? Or arcsin is another thing. So, arcsin or inverse sine of 1/2 equals pi over 6. The way this works, you put in the ratio, right? You put in whatever the coordinate is, the y value from the unit circle, and then the output is the angle. Normally, the input is the angle, and the output is the y coordinate on the unit circle. But now it's just we're switching the input and the output. That's it. Okay, that's basically the whole lesson here, except with some notation. Okay. Also, oh yeah, forgot restricted domains of inverse trig functions, right? So for sine, we restrict ourselves to being between negative pi or negative pi over 2 and pi over 2. If you were to take this graph and turn it, reflect it the way that we do for inverse functions, what you'd end up with is uh, something like, let me try to draw it a little straighter. You know, it would look like this. And we can't do that. That's not allowed when it comes to functions. And so we cut off this thing here. And so it's only this part that we're dealing with when it comes to inverse functions. Okay, so our restricted domain is negative pi over 2 to pi over 2 for sine, and for cosine, we restrict ourselves to 0 and pi. Okay, so um, for tangent function, we go from negative pi over 2 to pi over 2. All right, we basically take one cycle, the middle cycle of the tangent function, and we take the inverse of that. Okay, that's where the vertical asymptotes lie at negative pi over 2 and pi over 2. Okay, um, so when we look at that in the unit circle, here's our range that we're talking about. Inverse sine is the right side of the graph, the right side of the unit circle, quadrants 1 and 4. The restricted domain for the cosine, inverse cosine function, is the top half, so 0 to pi. And then again, tangent negative pi over 2 to pi over 2, so quadrants 1 and 4 for that. So now we want to evaluate the following expressions. So inverse cosine of negative root 2 over 2. Well, negative root 2 over 2, that's the pi over 4, but it's negative. And so realize that, if you're using the whole unit circle, there are two possible answers for that. We're not restricted domain. And so this means we're in the second quadrant because cosine is just inverse cosine are restricted to the first and second quadrants. And so this is going to be 3 pi over 4. Okay, so inverse sine of negative 3 over 2. So my negatives for inverse sine are in the fourth quadrant. And so the other thing I need to remember is that my restricted domain is from negative pi over 2 to pi over 2. So negative, that's going to be like over here, okay? And so that means I'm actually going this way, negative. I can't go all the way around the circle. And so this is going to end up being negative. And if you look at the unit circle and see where that is, that's negative pi over 3, right? That's 1/3 of the way around the bottom of the circle. Okay, an inverse tangent of the square root of 3. So the way that I would get square root of 3, right? So that's 3 over 2 over 1/2. That's the, sine cosine thing coordinates. Those are the sine cosine coordinates that reduce to root 3. And so that means I have a sine coordinate of root 3 over 2. And so this is just going to be pi over 3. Good. So now here, example 3, there's an angle in standard position right there, and we have the point P. Right? We've seen these types of things before. Points Q, R, and S are the terminal ray being reflected again. And so for the following expressions, we want to determine the labeled point which labeled point intersects the terminal ray of the given angles. So inverse cosine of x would be point P, right? So x, positive x coordinate. Since it's cosine, I'm restricted to being between 0 and pi. And so that's the one, right? So I'm restricted to this, but it's the positive. Oh, did some interesting automatic correction of my squiggle. I was just trying to highlight that area. Anyway, the top half of the circle, positive x, so that's P. Inverse sine of negative y. Okay, so inverse sine, I'm in the first and fourth quadrants, so I'm somewhere in here, and it's the negative of the y, and so the answer here is going to be S. And then inverse cosine of negative x. So again, negative x means that I'm going to be in this top half somewhere, or cosine means I'm going to be in the top half from 0 to pi, and it's negative x, and so that's going to be point Q. That didn't go well. Erase the wrong thing. And so now inverse tangent of negative y over x. It's interesting, right? So tangent here. So where can I have a negative y to x ratio? Well, in the first quadrant, they're both positive. So quadrant 4 is the place where I have both of them, and the y is negative, even though the x is positive. And so this is point S. Notice R didn't come up anywhere. R is lonely. We left him out. We are biased and prejudiced against that letter, so we don't include it. No, it's just that that's not in any of the domains, right? The domains are for cosine are 1 and 2, and the domains for uh, sine and tangent are 1 and 4. So domain 3 or quadrant 3 is not in any of the restricted domains for our inverse functions or arc functions. Okay. And so just on that notation, right, because it didn't come up anywhere. So inverse sine or arcsine mean the same thing. Thanks for watching. Don't forget to like and subscribe.